stars racing towards our planet. It's not a rumor, a real interstellar comet.
The conversation around 3I Atlas shifted from anticipation to interpretation. That date marked the most concentrated global observation window since the object was discovered, and while it did not deliver a single dramatic reveal, it quietly delivered something more valuable.
In the black, something is moving fast. Interstellar Comet 3I Atlas. A visitor from beyond our solar system is now blazing a green trail across the night sky.
Clarity. The data collected before, during, and after that window has begun to settle some of the biggest questions surrounding this interstellar visitor, while opening new ones that will guide observations in the weeks and months ahead. One of the first things astronomers learned is that 3I Atlas behaves far more like a natural body than an anomaly. Its trajectory remains consistent with purely gravitational motion, within the limits of current measurement precision. No unexpected course corrections. No sustained non-gravitational acceleration that cannot be explained by known processes. This alone removes a large amount of speculation from the table. Interstellar does not mean unpredictable. In this case, the object is moving exactly as physics says it should. Activity levels were another focus, and here the results are subtle but important. Observations around December 19th confirmed weak but detectable activity. This activity is not explosive and not dramatic, but it is real. Spectral data indicates the presence of gas release at low levels, consistent with the slow sublimation of volatile compounds. This supports the idea that 3I Atlas is not a completely inert rock, but a body that retained at least some volatile material despite its long exposure to interstellar space. Color measurements reinforced this picture. The faint green emissions detected align with known cometary processes, particularly those involving carbon-based molecules. The signal is weak, but its consistency across multiple instruments strengthens confidence in the result. This means the object is not just reflecting sunlight. It is interacting with it chemically.
Did 5 billion tons of matter really vanish into thin air without a trace? That's the massive amount of matter ejected from the mysterious interstellar object we call 3I Atlas.
That interaction provides direct insight into the composition of material formed around another star. Rotation data collected during this period helped refine estimates of the object's spin state. Brightness variations suggest an irregular shape with a stable rotation pattern, rather than chaotic tumbling. This is significant because it implies internal coherence. The object is not a fragile aggregate on the verge of breaking apart. It is a structurally intact body that has survived both ejection from its home system and a long interstellar journey. Size estimates also improved. By combining optical brightness with thermal measurements, astronomers were able to narrow the range of possible dimensions. 3I Atlas appears neither exceptionally large nor unusually small for an interstellar object, which has implications for how common such objects might be. If this size range is typical, then interstellar debris may be far more abundant in the galaxy than previously assumed, passing through planetary systems regularly but rarely being detected. Just as important are the things that were not seen. No artificial signals. No unexplained emissions. No geometric features inconsistent with natural formation. These non-detections matter. They set boundaries. They tell us not only what 3I Atlas is, but what it is not. Science advances as much by ruling out possibilities as it does by confirming them. So what happens next? As 3I Atlas continues its trajectory, it will slowly move away from optimal viewing geometry. That does not mean observations stop, but it does mean they become more challenging. The object will grow fainter, and subtle signals will require longer exposure times and more sensitive instruments. Ground-based telescopes will continue tracking its position, brightness, and color, refining orbital models and monitoring changes in activity. Space-based observatories will play an increasingly important role. Infrared observations can reveal how quickly the object cools as it recedes from the sun, providing clues about surface texture and thermal inertia. X-ray monitoring, while difficult, may still catch intermittent interactions with the solar wind if low-level outgassing persists. Each wavelength adds a layer of understanding that visible light alone cannot provide. There is also the question of comparison. 3I Atlas will not be studied in isolation. Its data will be placed alongside observations of previous interstellar visitors and compared to models of ejected debris from other planetary systems. Similarities and differences will matter. If multiple interstellar objects show comparable compositions and behaviors, that points toward common formation pathways. If each one looks radically different, it suggests a much wider diversity of planetary systems than we currently imagine. Theoretical work will accelerate as well. Simulations will be adjusted to account for the observed properties of 3I Atlas. Researchers will test how easily such an object could be ejected, how it could survive radiation exposure, and how often it might pass through systems like ours. These models help turn a single detection into statistical insight. Public fascination will likely fade as headlines move on, but within the scientific community, the real work is just beginning. Papers will be written, debated, revised, and cited for years. Data gathered in this brief window will continue to yield results as analysis techniques improve. What looks like a quiet ending is actually the start of a long afterlife in research. There is also a broader lesson here. December 19th did not deliver spectacle, and that is a success. It demonstrated that our instruments, methods, and expectations are aligned with reality. We prepared for something unusual, and when it behaved naturally, we learned anyway. That is how progress works in astronomy. The universe does not perform on cue, but it always has something to teach. In the end, 3I Atlas will leave our solar system the same way it entered it. Quietly. No farewell. No sign it was ever here. But for a short time, it allowed us to study material from another star system up close. After December 19th, we know more than we did before. And what happens next is not a dramatic event, but a gradual accumulation of understanding, built from faint signals, careful measurements, and patience.
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.